Good morning, everybody. It's Max McAllister here from Traxxion Dynamics with the long-awaited 2020 Honda Goldwing suspension review. Now, what we have here is not a whole bike. I just got shocks in from a 2020. Honda has claimed that they've revised the suspension on the bike to take away some of the initial complaints that people had of, ill-forming or too soft a suspension. I have many videos on this topic, and supposedly Honda's reacted to customer desires. Now in 2012, they claim to have made massive suspension upgrades to the previous 2018 Honda Goldwing, and we did review on that here. All they changed was they took 10 weight oil out of the right fork and put 20 weight oil in it. They added a small metal rib under the triple clamp, and that was it. That was the entire change. And magazines jumped up and down and said it was so much better than the previous bike, but it wasn't. It's exactly the same with a nickel's worth of thicker oil in the right fork. So my speculation is we're going to find that they have not changed the suspension on this bike in any significant way, because that is how Honda does it. Once the bike comes out, it's going to be that way forever. What we've got is a set of 2020 shocks that were shipped into us. They're in a sealed box. I haven't opened it. It's come from Knee Cycles. The owner was Scott Zorn. He's donated us these shocks. So what's in there? We don't know. If you come on around, we're just going to kind of get going on this. This is a shock dynamometer. We have a pair of shocks from a 2018-19 Honda Goldwing. They're the same. They're tour models, so they have the electronic damping adjustment in them. That's what these will have. To expedite this video, we've removed the block off of the bottom of the shock. We've got some adapters for our shock dyno. This is a front shock, this is a rear. And so we've removed the electronic damping adjusters from the shock. And then we have an adapter that we've made that we can just set the damper from minimum damping to maximum setting, read what the shock does on our dyno. We're going to do all that live and try and get this onto a video. So we're going to do multiple things at once, so we can go ahead and start this running. Shock dynamometer is a machine that measures the damping force available in both compression and rebound on the shock. There's a load cell here that reads it, transmits it to a computer, generates a graph. We're going to do all that in one contiguous motion here. To compare spring rates, if the springs are the same and they haven't changed, they'll be the same free length wire diameter and have the same number of coils. So that's how we'll know that. We're going to be doing two things at once. So Martin is just going to be doing his job of putting the baseline dyno runs on the 2018 shocks. We're going to leave them right on the screen. From Scott Zorn in Springfield, Illinois, he says, sending the stock shocks to you. Here they are. That's from Knee Cycles. All right. Here's the front. Here's the rear. Let's see. This is interesting. So one of the problems with the first shock was the bumper. So they have changed the bumper material in this. When we get the spring off, we'll be able to see that a little better. But the bumper material has changed, so that's different. You recall we had problems with this getting cut early on, and pieces being taken out of it by the dust cap on the shock. So let's start real quick. This is a rear spring off of the preceding model bike. It's free length, 169 millimeters. A few millimeters of variance will be, well, these are spot on, 169 millimeters. Wire diameter, 12.51 millimeters, 12.49 millimeters. This is the same 0.02 of a millimeter is, you know, literally nothing. That's could be the thickness of the paint. 1, 2, count coils. 1, 2, 3, 4, 5, and a 6. 1, 2, 3, 4, 5, and 6. Springs are the same. So we're not even going to put these on the rate testing machine. It doesn't matter because they're the same. So nothing's changed on the spring rate there. I'm going to let on the rear spring rate. Let's see. You got an adapter for this?
Yeah. Use
This?
that. Yep,
This?
that, just like that. Fine.
Yeah.
And then there's a big order.
All right. So, let's see. You have to compress this front spring. One warning about our video, we're trying to make it contiguous here. Just because the first time we did videos and I pointed out that I thought the suspension wasn't very good, I got all kinds of hate mail and people accusing me of doing all kinds of false testing and false analysis because I, for some reason, had some vendetta against Honda, or which I don't, or the Goldwing, which I don't. So that we're just trying to make this as contiguous as possible so that nobody can question what we've done here. So what I'm trying to accomplish here is removing the circlip that retains the spring. Man, it is happily placed in that groove. Trying to get the spring out of here. The clip. There we go. All right. You just keep doing what you're doing. You got a trick to this, Martin? You got a trick? I'm not getting it. Oh, you've done it all the way up. Okay, I see what you're doing. Smush it more. All right, thank you. All right. I got it. All right. Okay, front spring. We're going to compare those real quick. Free length, 137-ish millimeters. 137-ish millimeters. Same free length. Wire diameter, 9.05. Wire diameter, 9.11. So same that wire diameter. That's tolerance and or spring, powder coating thickness. Coils, 1, 2, 3, 4, 5.5. 1, 2, 3, 4, 5.5. So exact same springs. So they did nothing to change the spring rates, which in my opinion are too soft. And in particular, the front is incredibly way too soft. All right, so now what do we see is different? They did change.
10 minutes.
Or is it still tracking? Well, our this video stops. Okay, good. We've been having trouble with my video stops at 10 minutes. So they did change the front bumper quite a bit. So that's interesting. Oops, I got the wrong shock. There. I was like, that has too many clip grooves. Here we go. This is what I'm looking for. Too many clip grooves. Here we go. So the bumper is different. It is shorter, so I guess they've left more of a gap. As you recall, if you just put the bike down and sit on it, the 2018 model shock, all of the shock travel would come down and it would basically sit on the bumper. They've taken about 5 millimeters out of that. It's about 33.5 millimeters. This was 37.5 millimeters, so about 4 millimeters, the shorter bumper. The material's different. I don't have any way to give you a durometer test. It is significantly, it's a harder bumper. So, you can watch me squish this material with my fingers. This one is not like that. So the bumper is much, much harder. That difference, this is kind of a two-stage bumper. This one is designed to give a smooth transition between no bumper and bumper. So this two-stage effect in the soft bumper, this will make a hard bumper like this will give you a dramatically noticeable change in feel as it comes down and hits that bumper. And this will give a much bigger rise in rate over the preceding style of bumper. So while I would say this one is less prone to damage, this one will not function in my mind as well as the older one. You will feel when that comes down and touches that, that will be visible or noticeable to the rider. In a moment, we'll have this off and I'll be able to play with it a little bit. So in the interim, where are you at, Martin?
Just bought on.
With which stock is this?
One brown and up and down, ready for the new shocks.
Okay, so what we've done is,
Good brake test.
let's see, yeah, the little bumpers, we might try that.
Yeah.
One of the curiosities we're wondering is, let's see if there's any change in stroke or anything. So that's the 66 mil. And 54, a little less, about 54 mil. I think those are exactly the same. So now what we're going to do is remove the eyelets and the electronics from the bottom. Do we want us to open those, take those, the motor, or can we just heat that with it fully assembled, with the base?
I'll just take the shaft out.
Okay.
Screw shaft.
Good. Aren't they Loctited in?
Yeah.
Good.
Good. I got everything ready.
Oh, you got it all in? Okay. All right. Okay. So on the shock, to make sure that the test is, all kind of even and the same, we use a thermocouple. This transmits the temperature of the shock because, a warm shock functions differently than a cold shock. So to remove the stepper motors and the lower clevis, we have to heat the clevis to make sure that the Loctite in it kind of becomes liquefied a little bit so that we can, you want me to hold that up? Obviously, they do not want the shock coming apart under use, so it's Loctited and then has a big jam nut on it and the whole nine. So. So here's dyno graphs from the stock shocks. You'll see two different ranges. One is with the shock set at minimum damping, and one is with it set at its maximum damping available. This is an average. This line represents an average of the compression damping forces. This line represents an average of the rebound damping forces in the minimum and maximum positions. All right, so Martin's got this one apart. All right, here's bumpers. So here you can see the differences between these. Hugely different bumpers. So I can mash that to the floor. This one I stand on it and it just compresses slightly. So I'm actually, don't weigh enough to get that with just my arm. See, I can work that bumper. So that's a big change. You see, here at our shop, we wouldn't just try and put a stiff bumper on a shock. We would change the spring because the spring's too soft. So anyway, I guess we could try and squish that, huh? While Martin's taking that other shock apart, we'll see if we can just squish one. Tell you, come up with some way here. It's not much. I need something to put under that. Do something like this. Just throw that in there. All right, so I've got it to where it's just touching. We'll zero everything. Actually, I can't. I've got to get the slack out of the system. Unfortunately, I got to put a little pressure on. Oh, here, I can do this by hand. We'll zero that. Zero that. Now let's try. We can smush this. This is actually kind of cool to watch if you want to get up in there with the camera. Watch the bumper. So you can see that first stage compress. Now we're going to get this up to about an inch. And just see how much pressure it generates. All right, 170 pounds per inch. We're going to call that close enough. Let's grab the new guy, new kid in town. Let's see what the difference is. This one's stiffer. We should be able to get the slack out of this. Okay, that's. All right, we'll zero that. Zero that. Oh, look at that bumper. Look at that thing. So this has less range than the, it's going to go crazy exponential here. All right. There's 1 inch. 915, so it's over 900 pounds per inch. So, wow. All right. That's on the front. So, what this does is, so the bumper in conjunction with the stock mechanical spring work collectively to form one single spring rate. In this case, an incredibly progressive spring rate. So once this shock has compressed about an inch, it'll get down to where it touches this bumper, and then it will begin to go extremely progressive in nature. So anytime the bike is riding in the bottom half of the travel, it's going to be less compliant, unfortunately. So this is not an improvement on the 2020. This is actually a setback in my humble opinion. Hey, but what do I know? Then looks like Martin's probably got the second shock apart. See if there's any difference in the rear bumpers. I don't think I can probably. Well, it is different, isn't it? Let's just see. That's. Huh. Well, while Martin's working, I'm just gonna smush these a little to smush them. These are only an inch long, so I can't really even compress these an inch to see what they do. But so we'll do half of that, and we're just going to do half just to see if they're the same. 0, 0. I went a little too far there. Close enough. Call that 260 and a half of an inch. Put this in here. All right, 0 that, 0 that. Actually says it's a little softer. Interesting. Let me just make sure I zeroed it properly. Zero, zero, zero. I was not suspecting that this was going to change.